Hello dear friends, welcome to the lecture of geometry. We are studying the plane. In this lecture we will study bisectors of angles between two planes. I have written the results here. This is a simple result and so little bit descriptive. To save the time I have written the result. We will see the meaning of this, and after seeing the result we will solve the problems on this result. First we will see what is the meaning of bisector of angle between two planes. You may see, if we consider this book, then these are the two planes and this is bisected by another plane that can be considered as again it will be a page, and that this is the bisector of angle between these two planes. If it makes, the condition is if it makes equal angle with both the planes. So this angle between this first plane and the bisecting plane must be equal to the angle between the second plane and the bisecting plane. So it makes equal angle with both the planes, then that is the bisecting plane. So it will be a bisecting plane. Just as a bisecting line, so what does it mean? If these are the two lines, then a line which bisects the angle between them. Again there are two types of angles formed. One is acute and other will be obtuse. This is obtuse. And if you consider the acute angle, then this line will bisect the angle between these two lines, given lines. And if you consider the obtuse angle, then there will be another line which bisects the obtuse angle, this angle between the two lines. Likewise, there will be two planes. One plane, now this is a three-dimensional concept you should imagine. So this is the infinite, plane is infinite. So for example, we are considering this finite object, but it can be extended on this side, and this plane can be extended on this side. So this is one bisector, another angle will be formed here, and that plane will bisect that angle, obtuse angle or acute angle it may be. So thus there are two angle bisectors or two bisector planes between the two given planes. So this is the meaning of bisector of angle between two planes. And again, what is the condition for bisecting plane? If you consider any point on this plane, then the distance of this point to this first plane and the distance of the point to the second plane must be the same, because it is equally placed, or it makes equal angle with both the planes, and therefore the distance of any point on the bisecting plane to the first plane and the second plane will be the same. So this result we are going to use, and that gives directly the result for bisector of planes. So here what we have considered is to find the equations of the bisectors of the angle between these two planes. These are the two given planes, and we have to find out a third plane which bisects these two planes. Now there are two bisectors of planes, as we have seen. For two lines, there are also two types of angles made. One is acute, another is obtuse. If the lines are not perpendicular to each other, then if we consider a point P, on the bisector plane, then its distance from both the planes must be the same. The same thing happens for the lines also. If you consider a point P on this bisecting line, then its distance to this first line and the distance to the second line is the same. And instead of line, here are the planes. So therefore the distance of P from the first plane is equal to the distance of the point P from the second plane. So that is the only result we have to use. So we have written here there are two bisector planes between two planes, and if P is a point on the bisector plane, then the distance of P from both the given planes must be equal. That is distance of P from the first plane, and we have to use the distance formula for distance of point and plane. Perpendicular distance of point from given plane, general equation we have to use, general plane we have to use, and this is a direct formula we have earlier seen, instead of x1, y1, z1, the point is considered itself as x, y, z. So therefore the coordinates, if you put here, it remains the same, x, y, z. So thus the expression or distance between these two is a into x plus b into y plus c into z plus d divided by under root of a square plus b square plus c square. And between this point and this plane, to denote the second equation of the plane or second plane, only suffixes are used. X, y will not change, only their coefficients. There we have written a, b, c, d, and here we have written a1, b1, c1, d1. That is a notation. So therefore the distance between this point P and this plane is on the right side. A1 into x plus b1 into y plus c1 into z plus d1 divided by under root quantity of a1 square plus b1 square plus c1 square. So only the distance between point and plane is used. And why there is plus minus sign? Because there are two types of bisectors. One bisects acute angle, another bisects the obtuse angle. Like this. So this bisects the acute angle between the lines and this bisects the obtuse angle, greater angle. Acute means less than 90 and obtuse greater than 90. So thus there will be two bisectors of the planes, and these are the two equations of bisecting planes. Simply we have to write these two expressions and simplify. That will give two equations of plane, two separate equations of plane. How to get two equations of plane? One will corresponding to positive sign, another will correspond to negative sign after simplification. And one of these bisect the acute angle and the other bisects the obtuse angle between the planes. So this is simple. If two equations are of the plane are given, we take a point and use the formula of perpendicular distance between point and plane. We get the direct relation, this relation. Simplify it, that gives the two bisecting planes. And one bisects the obtuse. Now how to decide which bisects the acute angle and which bisects the obtuse angle? So acute angle will be less than 90 degree, and if less than 90 degree angle is bisected, then the bisecting angle will be less than 45. So less than 90 is bisected. If the angle is less than 90 degree, or see if this is the angle, then if this is bisected, then certainly these two angles will be less than 45 degree. And that is what we have written here. The bisector of the acute angle makes an angle less than 45 degree. So acute angle, bisector of acute angle makes angle less than 45 degree, and bisector of the obtuse angle, bisector of the obtuse angle makes an angle greater than 45 degree with either of the planes, one or second, both the planes. It makes angle less than 45 degree and it makes angle greater than 45 degree. And then we can say that bisects the acute angle, which a particular plane bisects the acute angle, and remaining plane will bisect the two equations we will get. One of them will bisect acute angle and the other remaining will bisect the obtuse angle. So this is the only result we have to use. And now we will consider, we will solve the problems depending on this. So this we have to remember to write the bisecting planes. Now we consider the first problem. We solve the first problem. Solution for the first problem. So this I shall now remove, and we will write the solution here. Solution for first problem. See what is given. We have to show this plane bisects the obtuse angle between the these two planes, or actually we have to find out the bisector of these two planes, and we write solution for first. Let P be a point on the bisector of the planes, given planes. The given planes are, we will write the equations of planes first. Actually this is the answer. This is the answer that we have to obtain. And what are the planes given are these two. So we write the equations of given planes. The given planes are First equation is 3x plus 4y minus etc. We suppose it as 1 and so let P xyz be a point on the bisector plane. Then the distance of P from 1 and 2 must be the same. Then the perpendicular distance from 1 and 2 planes, from planes 1 and 2 must be the same. From the planes 1 and 2 must be the same, and therefore we have to use this formula. See, P is the point, the same xyz, here also we have considered, and what we have to write the same expression. So therefore we have, what is the expression? 3x plus 4y minus 5z plus 1 divided by under root quantity of a square plus b square plus c square. What are a, b, c? 3, 4 minus 5. So 3 square plus 4 square plus minus 5 square, and is equal to plus or minus. What is the right side? The second expression, that is as it is, 5x plus 12y minus 13z divided by under root quantity of a1 square etc. coefficients of x, y, z, 5 square, 12 square and minus 13 square, sum of this. So 5 square plus 12 square plus minus 13 square, and we have to simplify this. So this now can be remembered. So I shall remove this and we will simplify this equation here. Now you see the denominators, and what is the denominator here? 3 square is 9 plus 16 plus 25. 9 plus 16 that is 25 plus 25, it is root 50. So root 50, and that can be written as 25 into 2, or that will be 5 root 2. Root 15 is 5 root 2. And what about this? So I shall write this as 3x plus 4y minus 5z plus 1 divided by 5 root 2. And there is plus or minus sign. So because there are two planes. Or otherwise, if you consider the distance, then it is an absolute value. And absolute value has the two signs, plus or minus. And the second will be 5x plus 12y minus 13z divided by, see the calculations for this will be 25, 144, and that is 169. So it comes to be 338, and if you divide by 2, then this becomes 1, then 6 and 9, 169. So 2 into, actually this is the number obtained, and that is 2 into 169. Why we have written? Because root of this 169 is again 13. So therefore this is 13 root 2. You may check this. And now we can cancel out this term root 2, 1 by root 2 from both sides. And then further we should cross multiply. And thus after cross multiplying, what we will get? We should, after cancelling this root 2, we have to multiply the left side by 13, and that becomes 13 into 3, so that is 39x plus 13 into 4, and that is 52y minus 13 into 5, that is 65z plus 13 is equal to, plus or minus is there, this multiply by 5, so it is 25x plus 60y and minus 65z. So this much we have obtained after cross multiplying. And now we will have to separate the equations, two equations, one corresponding to plus and other corresponding to minus. So this implies two separate equations. So this implies, now if I take, you may consider the plus sign first, and then 39x plus 52y minus 65z plus 13 is equal to positive of this, and then I shall take all the terms on left side. That 25 on this side taken becomes minus 25, 39 minus 25 will be say this is 14x and 52 minus 60, that is minus 8y, and this is minus 65z, minus of minus becomes plus 65z, that cancels, z cancels, and 13 there is no constant, plus 13 is equal to 0. And now what about the second? Take the negative sign, and if you take the negative sign and when we add the terms to the left side, that gets added, so that will be actually 39 plus 25, and this is 39 plus 25, so that is 64. Should check the calculations. Yes, and 52 plus 60, and that is 112 plus 112y. And what about this? So it is actually positive, and when it takes on this side, it becomes negative. 65 minus 65 minus 65, that is 130 times z, and plus 13 is equal to 0. So thus we have obtained these two bisectors planes, bisector plane, angle bisecting planes. And now what we have to decide, which bisects the acute angle and which bisects the obtuse angle. Now how to decide? That means we have to obtain the angle between the first plane with this third plane, or the angle between second plane and the third plane. It must be the same because it is bisecting. So the angle between plane 1 and 3 and the angle between plane 2 and 3 must be equal. But that will be different for 1 and 4 and 2 and 4. So that is different because the one of them will bisect the acute angle and other will bisect the obtuse angle. So we are asked to show that this bisects this plane. We have obtained that here. This plane bisects the obtuse angle between the planes, these two planes. So we will find out the angle between 1 and 3. Now the angle between 1 and 3 is the angle. So we must first mention that these are the bisectors. Planes 3 and 4 are the bisectors of planes 1 and 2. Now we shall find the angle between plane 1 and 3. If theta is the angle between planes 1 and 3, then we have studied earlier how to obtain the angle between two planes, or we know the formula for that also. So I shall write it here. See the first plane and third plane only. You observe the first and third plane. See, the angle between the planes means the angle between their normals, and we know the coefficients of x, y, z represents the DRS of the normals. So what are the DRS of normals to the first plane? 3, 4, minus 5. And what are the DRS of the normal to the third plane? 14, minus 8 and 13. And the angle between these two lines, the formula is A into A1 plus B into B1 plus C into C1 here it is absent, z is absent, and that c into c1 divided by under root of summation a square into summation a1 square, like this. And therefore then we have cos of theta. Cos of theta is equal to see, it is 3 into 14, 3 into 14 plus 4 into minus 8 and plus minus 5, and there is no term of z here, and only this much divided by, there is no constant term in the formula of angle between two planes, divided by under root of 3 square etc. 3 square plus 4 square plus minus 5 square, one quantity, and other is this one, 14 square plus minus 8 square and plus 0 square. Or actually this is cos theta we are obtaining, and now you see this will be 42 minus 34. So 42 minus 32. 42 minus 32. This is 32, 4 into 8. And this is 42. So this will be 10. The numerator is 10. And this is what we have earlier seen as a 5 root 2 or root 50. This is root 50. And what about this quantity? This we have to calculate. 14 square, see the square of 14, 196. Check it. Yes, 196. And square of 8 is 64. And sum of these two, it is 0, last is 0. And sum of this is 260. So this is 260. This is what we have obtained is cos theta. And but from this so we can write it as 10 divided by, here root 10 into root 10 is again 10, so that we can consider as root 10, root actually it is 100, root of 100 is 10, this, and what remains is 5 into 26, and that I shall write in under root. So 5 into 26, you may check this, and thus the quantity we have obtained is that is 1 upon cos theta is 1 upon under root of 130. This is cos theta. Now how to determine theta? Whether theta is less than 45 or greater than 45, that we have to decide, and that cannot be decided by only cos theta. So to decide theta is less than or greater than 45, we have to obtain tan theta, and we know tan 45 is equal to 1. Tan 45 degree is 1, and if this quantity is equal to 1, the angle is 45. If the quantity is less than 1, the angle is less than 45, and if it is greater than 1, then the angle is greater than 45. So tan is required to decide whether it is less than 45 or greater than 45, and to get tan we have to obtain cos. Cos is obtained, we have to obtain sin theta, and then sin upon cos gives the expression for tan theta. So thus from cos theta, how to obtain sin theta? Using the formula. So we shall use the formula. Now sin theta is under root of 1 minus cos square theta, trigonometric formula, and that is under root of 1 minus square of this 1 upon 130, or that will be under root quantity of 130 minus 1, 129 divided by 130. So this is sin theta, and from this we will see now the tan theta. So what is tan theta? I shall write here. Therefore tan theta is sin theta divided by cos theta. And now see, this is divided by this one. The under root quantity at denominator disappears, and what we shall get is root of 100 29. So this is the value of tan theta, that is right. So tan theta is root of 129. You should check these calculations whether we have done correctly. So this is the procedure. First get cos theta, then get sin theta, then get the value of tan theta, and decide whether this quantity is greater than 1 or less than 1. Tan theta we compare with 1. So this is certainly greater than 1, because this is 1 is root 1 and this is greater than root 1, and therefore it is greater than 1. And tan theta is greater than 1 means theta is greater than 45 degree. If this tan theta is less than 1, then in that case we say theta is less than 45. So you remember, compare tan theta value with 1, either greater or less. If it is exactly equal to 1, then the angle will be 45, and thus theta is greater than 45. And if theta is the greater than 45, then it bisects the obtuse angle. So this is what we are asked to show. We have to show that this plane bisects the obtuse angle between the planes. So thus this shows that the plane 3, that the bisector plane 3 means this one, 14x minus y 8y plus 13 bisects the obtuse angle between the planes. And this completes the solution, bisects the obtuse angle between the given planes. And this completes the solution. Now, the second problem I shall leave you to solve, and try this yourself. The answer is given. Here what is asked is, find the bisector of the acute angle between these two planes. Exactly similar procedure we have to use. First write the perpendicular distance of point from both the planes, and then simplify it, taking positive and negative signs separately. We will get the two planes as of 3 and 4 here, and one plane you should take, and if that, as in earlier case, we have to find out tan theta. If it is less than 1, then that bisects the acute angle, and if it is greater than 1, that bisects the obtuse angle, and remaining will bisect the acute angle. If in this earlier problem, you should remember, if in the first problem, if it is asked to find acute angle, and if you have considered this, we don't know which will bisect the acute angle and which will bisect the obtuse angle. For we have taken this third plane, and if it bisects the obtuse angle, the fourth plane will bisect the acute angle. So no separate calculation is to be done for the remaining plane. If we taken third, you can take third or fourth, one bisector plane, and that will give one result. Here we have obtained it bisects the obtuse angle, and third plane bisects the obtuse angle means fourth will bisect the acute angle. Here you solve this problem in exactly similar way, and if you get the two bisector planes, if one of that is third for this problem bisects the acute angle, that is the answer. And if it again bisects the obtuse angle, the remaining will bisect the acute angle. So one result is sufficient to decide which bisects the acute and which bisects the obtuse angle. So please solve this second problem yourself. Thank you.